Alright, so but most of the time what you're going to be doing in your biochemistry career are scatter plots. So here we're looking for correlation between our two sets of numbers. And we, instead of drawing every point, we draw a line of best fit. Whoa. And yes, we're looking at the general trend of the data, not at the individual differences. So here, if I joined up all my data, it would kind of go up and down and be quite uneven. So here's my other imaginary data set that I've made. So we go do, 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 do. But in fact, you can see the important thing that we want to look at here is that the data is increasing. So as our independent variable drawn on the y-axis goes up, so too does our dependent variable on the x-axis. And both of these are quantitative continuous measurements. So that's a requirement for drawing a scatter plot. Okay, so we're not really interested in the exact difference between this data point here for 1 and 1.5. We're interested in the general trend that's going up, and that shows a correlation. We're looking. So this correlation means that they are related together. So, as I say, as x increases, so y decreases. Sorry, increases. Alright, so now we need to draw a line of best fit through the middle of these. So the key here, so first of all I'm just going to draw a line. So the key here, and then I can move it around. What we need to do is we need to get it as good as possible in the middle of our different points. So we want it to be going through the middle, so it's as many, so there's the same number underneath and over the top of the line. So you've got 1, 2, 3, 4, 5, 6 underneath, only 2 above. That's no good. How about if I put the line back like this? 1, 2. That looks pretty good. And then we've got these 2 points that are quite nicely on the line of best fit. Then these are quite far away. Anyway, so you have to fiddle around with it. And when you're doing this for yourself, you have to use a ruler. Just put your ruler through the middle of the lines. And it's easiest if you use a see-through ruler, because then you can see more easily what points are on either side of your line. So I think that'll do. That's my best attempt. Yep, so this is my estimated here. Do you know what I'm going to write little crosses for all my data points? It's probably easier to see. So here I've just done my best, and this is all I'll ask of you in the practical lab, to draw our line of best fit through the middle. And we could describe this line using the tools that we learnt in the previous video. So we can describe it using the slope and the intercept, and we could make an equation of this line if we wanted. Alright, and another thing that this line is useful for is to interpolate or extrapolate more data points. So when I say extrapolate, that means that we can extend this line beyond our measurements, but we have to be careful with that, because if we extended this hundreds and hundreds along the x-axis, that might not be accurate anymore, but we probably could a little way. And what do I mean by interpolate? That means that we're looking at points kind of within our data set. So for instance, imagine that I have an x value of 3.5 and I want to predict roughly what the y value is going to be for that. So we could go up from 3.5 till we meet the line, and then across. That's about 2.75, so that's a good estimate. So this is an interpolated data point. Okay, so let's write those here on the general summary, so we can interpolate or extrapolate.